Hello! In this video, we're going to derive the identity for sine of a plus b. And we're focused on the case where we have an acute angle plus an acute angle, which is an acute angle. And so let's draw a diagram of our angles. We'll start by drawing angle A. And let's draw angle B. Right, so notice I've drawn angles A and B in such a way that they're both acute angles. And also, when we add those angles together, we get angle A plus B, which is also an acute angle, right? And that's really the case we're focused on. Now what I'm going to do is I'm going to drop a perpendicular from this point onto this line. Next, I'll also drop a perpendicular from this point onto the x-axis. And so at this point, notice we now have a right triangle containing angle A, a right triangle containing angle B, and a right triangle containing angle A plus B. But we also have another right triangle in here, right? We have this right triangle. And it turns out that this angle is equal to angle A. And let me prove that real quick. Notice that we have a right triangle here, and because this angle is angle A, this angle must be 90 degrees minus angle A. The reason why is, if you recall, the two acute angles of a right triangle must add up to 90 degrees. And since these two angles are vertical angles, they must be equal. So this angle is 90 degrees minus A. And similarly for what we have here, we know that because this angle is 90 degrees minus A, this angle must be A, right? Because the two acute angles of a right triangle must add up to 90 degrees. So yeah, this is a right triangle with angle A. Now what I'm going to do is I'm going to give each of these side lengths some names. So really we have side length A, B, C, D, E, F, and G. So hopefully that labeling is clear. But now we want to show that the sine of A plus B is equal to this. Now really, the sine of A plus B is just opposite over hypotenuse for this right triangle. So really we have sine of A plus B equals B plus F over G. And really this is just B over G plus F over G. Now what I would like to do is I would like to re-express what B over G and F over G are in terms of trig ratios. And so that's really my next goal. And we're going to start by re-expressing F over G. Now, it may not be obvious why I'm doing what I'm about to do, but it all works out in the end, right? That was good. I like that. You got to admit, that was good, right? Right. But what I'm going to do is I'm going to divide both the numerator and denominator by FG. Right? That's perfectly legal. I'm just dividing both the numerator and denominator by the same number. And we know that the numerator is just 1 over G, and the denominator is just 1 over F. Next, I'm going to multiply both the numerator and denominator by E. But really, if you look at the triangle containing angle B, we say that the sine of B is equal to opposite over hypotenuse, which is E over G. So E over G is the sine of B. In addition, we see for this little triangle that the cosine of A is adjacent over hypotenuse, which is E over F. So really, E over F is the cosine of A. And so now we have re-expressed F over G in terms of trig ratios. And so that's exactly what we wanted to do. Now we're going to do the same thing for B over G. Now it turns out re-expressing what B over G is in terms of trig ratios is actually a little bit more complicated than what we have here. But we will still get through it. So really, B over G is the same thing as B over C times C over G. First of all, notice that B over C is just the ratio of these two side lengths in this right triangle, right? Sine of A is opposite over hypotenuse, which is B over C. So I can replace B over C with sine of A. Now, C is just C plus D minus D. And really, I can break this fraction up into c plus d over g minus d over g. Again, you're still probably thinking to yourself, why did I do this? But notice it is useful because c plus d over g is just the cosine of b, right? Cosine of b is adjacent over hypotenuse. So yeah, cosine of b is c plus d over g. So really, what are we going to do with d over g? Well, we're going to do a similar thing to what we did right here, right? D over g is just d over e times e over g. And now we are in a good position because d over e is just the tangent of a, right? Tangent of a is opposite over adjacent. E over g is just sine of b, right? Opposite over hypotenuse. In fact, we evaluated e over g right here. And so this is it. We've re-expressed f over g in terms of trig ratios, and we've re-expressed b over g in terms of trig ratios. So really, we're ready to plug in b over g for this thing and f over g for this thing. Okay, so for b over g, I'm just going to write this in its place. As for f over g, I'm just going to write this in its place. Okay, so sine of a plus b is equal to this. All we're going to do now is show that this and this are trig identities. So I don't need any of this anymore. Okay, so how do I show that this is identical to this? Well, we sort of just have to work with it, right? That was good, right? I like that, right? So, remember, our goal is to show that this is identical to this. That's what it means to be trig identity. To start, I'm first going to distribute the sine a across. So next, it turns out it's going to be particularly useful if we combine this all into a single fraction. To do that, our common denominator is going to be cosine of a. So for this first term, I'm going to multiply by cosine of a over cosine of a. As for this term, it turns out tangent of a is sine a over cosine a. So we already have cosine of a in the denominator for this term. I'm just going to re-express tangent of a as sine a over cosine of a. And let me just rewrite this term. So as you can see, we have the same denominator in each of them, so we can combine this all into a single fraction. Okay, so next I'm just going to swap these two terms. Now notice, in these two terms, I can factor out a sine b. And of course, 1 minus sine squared a is just cosine squared a. And notice, these two terms, we have cosine a, cosine squared a, cosine a. So, cosine a's go away, and cosine squared a becomes cosine of a. Right? So things cancel out, and as you can see, we're left with sine a cosine b plus cosine a sine b. And so we have derived exactly what we wanted to derive, right? As you can see, it's just a chain of equalities, where going from here to here, we derived that before, right? Using this diagram, right? But basically, it's just a chain of equalities all the way along, right? It's really cool. So yeah, we have shown that this identity is true under the case where we have an acute angle plus an acute angle equals an acute angle. And so, yeah, that's pretty much it for this video.